Guys, you gotta help me. A black cat just strolled in and took all my files and just went away. I mean, I was just standing there. I couldn't do anything. It was a very cute cat. Now, what do I do now? Recover important files on your network was downloaded and encrypted. See, recover this file to get further instruction. No, why would you do it? How can a cat do this thing? I'm very interested. Well, it's time to find out then. Time to find out how Black Cat Ransomware works. And I'm going to do a static analysis reverse engineering on it to exactly answer those questions. How is Black Cat Ransomware spreading itself, encrypting all our files and directories and every important stuff that we have on our computer, and how it's doing other malicious stuff on it? Welcome to this three-part series on Black Cat Ransomware reverse engineering analysis. I will hope you all like it. And now, roll out the intro. All right, so here we have our Black Cat Ransomware binary in here. And I've actually downloaded this binary from VX Underground, so you can go ahead and check it out yourself there. They got lots of malware samples in here. The first thing I want to do is I want to check the file type of this one. So issuing a file command on Black Cat Ransomware says that it's a PE32 executable GUI. It's stripped to external PDB for MS Windows. So we know that this is a Rust binary from dynamic analysis, and we know that this is essentially a ransomware as a service kind of stuff. So as you can probably remember, if when we saw that in dynamic analysis, it spits out some strings before actually doing its work. So it's basically like a red teaming tool here. So let's go over to Ghidra and try to find those strings in here first of all. Now, we can also do it from our command line, but it might get some messy. So I prefer to actually find it on Ghidra and then cleaning up on a note. So here we go. The first thing we find is something about VM kill stuff or something like that, and we find it. So this is a string that is essentially the help string or the string that is first launched when you first launch the malware from your command line. It's have all the options that you would want to use what options should the malware use to infect and so on. I have cleaned this up and here we are. Now we can see what the options are here. Obviously we saw this on dynamic analysis, but here we are again. So let's go over this one by one. It's paths log file, no VM kill. Looks like it's doing something with virtual machines, do not stop VMs on ESXi. Looks like it is going to no propagate servers, do not propagate to defined servers, then run as a child process, log into console. This is important. This verbose option will get important later on, because if we run this verbose option with it, it will spew us a bunch of information about what the malware is going to do. So log to console, then access token. This access token is a guess of mine that when you buy this ransomware from probably dark web or so much of the shady places, you can get an access token to see that you're authorized to use this malware or so on. Like I think that's what it is, because there is going to be another token which is going to be appended on when the wallpaper changes, when the malware has done its work. We'll get to it later. Then log file, enable logging stuff to a specified file. Then we have note file name, note full text, note short text. We'll be getting to this soon. And it's kind of like this one here: enable EXSI VM kill, enable self-propagation, enable set wallpaper, enable network discovery. So it's kind of like options here, what it's asking you, what you're trying to do. It also has kill services and kill processes and cipher modes. Now these options, these things will get very much important when we deep dive into the malware, go into hardcore reverse engineering stuff in here. Right now, we're just analyzing strings to take an educated guess on what the malware is going to do, what the malware is trying to do, and how it's trying to change some things. We're just observing that right now. So the next thing I want to actually check here. So we know the options that the malware actually shows us. The next thing I want to show you now is what happens when the wallpaper changes. So when the wallpaper changes, there's also a bunch of information on the screen, right? Now, to check that, it's basically on a config file. And here we are with the config ID in here. Again, I have cleaned this up, and here we go. I can properly show you this. So this is the config file, and so it also has the threat, which is in here. As you can probably see that it's important files in your system was encrypted, and now they have this extension. So it probably has this some sort of extension which the malware is trying to use. Sensitive data on your system was downloaded, and it will be published if you refuse to cooperate, and so on. So this is a big threat, and it will appear on your wallpaper. If it will appear in your wallpaper, it sets up the wallpaper as that way. It uses the system parameters to do this. Again, we will look at it again. We'll look into it later in part 2. Interesting thing here is that this links to an Onion website in here. Obviously, private preview is published here, so you can probably go to this place and see that they're not joking, that they're really serious. And it also shows the recovery procedure. You have to navigate to this another Onion website, access key. This access key will be built up, the malware will build up the access key and send it to them probably, so that your case remains unique. We'll see later that this access key is generated using WMIC to get your computer to get your UUID with that thing. And it also, the important thing here is, after all these things, the important thing here is it obviously gets the credentials from your computer. When I downloaded the sample and tried analyzing for strings, there was a bunch of credentials in here actually, because this was a malware sample. So I've actually deleted all this and just said redacted for safety. So you get the point. So it got the credentials and it kills services. And you see it's killing a lot more services, a lot more processes. It's killing these services and processes because it doesn't want that to interfere with its cryptographic process, with its encryption and those kind of stuff here. In kill processes, it's killing a bunch of processes, to be honest, a bunch of processes, many processes. And it's also using the enable network discovery, which is discovering some network shares if it's available, probably using the credentials it found in this place, probably reusing that to see if another computer can be unlocked, if another computer can be reached by that, can be used for lateral movement or for horizontal movement or for vertical movement. It solely depends upon what configurations you use in the wall in the starting screen. So you can actually say that it's kind of like a red teaming tool here, but again, it's doing some very bad stuff with your PC. It also has the enable set wallpaper here, which we know it's set to true, which we know it's actually really setting up your wallpaper. Exclude file path wildcard, you can also set this up. And enable ESXIVM kill is true, and strict path includes this. So you can see that it's killing a whole lot of processes in here. Really, I mean, whole lot of process, and kind of killing here. Exclude file extension. It's excluding these file extensions though. It's not deleting anything, or it's not killing anything with .exe or .ic or .ocx, which is kind of interesting in this case. And I think there it is with the strings in here. Another thing that I want to show you here is the thing that it actually want to talk about, that this thing we found here, which is access key. Now, access key is actually built up using the direct command that this malware sends to your computer, which is a WMIC command. Let me just go to Keydra and show you. So if I type on WMIC and search it, it gets this string value of WMIC CS product get UUID. It's getting the UUID, and then it's appending that to something else and putting it onto your wallpaper screen. On the thread screen, this is probably your access key. The UUID, it's issuing this WMIC command to get your user ID on your computer. So it's very interesting in here. Another thing that I would like to show here, if we are showing this thing. So let me just look at this thing. So I found this interesting thing from this Black Cat Ransomware things when analyzing strings here. So if you go to, if you search for, if you grep for locker, it's kind of, oh wait, I think I have it on my notes in here, kind of messed up. Yeah, this thing. Let me just kind of maximize the font so you can see. So now I don't have experience with Rust binaries. I think this is my first reverse engineering a Rust binary, and this is going to be a malware. But I can see that Locker, Core, Windows, we will also see in later stages that they use Cargo. Now, Cargo is, if I'm not wrong, it's a Rust package management system. And you can clearly see that something is going on in this thing. So the reason I say this is because we see psexec here. Now, psexec is not a malicious tool. It's really not a malicious tool, but it can be used in a malicious way, because if you have credentials, psexec, what it does is it allows you to log into a system using those credentials. So psexec essentially can be used as a privilege escalation tool, or it can be used as a, maintaining privileges or spreading to other computers. Because to be honest, I have used psexec and crackmapexec, those things are a lot, or evil WinRM a lot when I'm doing stuff on Active Directory or stuff in here. Another thing that I've seen here is very interesting is that, before I forget, it's also using -accept EULAX. We generally do that because if you don't have GUI access, you might as well pass this argument in the command line so that it runs. Sort of like what we do with sysinternal suit. We also have hidden partitions here with a $sign. So this is a partition level. It tries to, I think, when we will go to the reverse engineering portion on how it gets the volume information and what it tries to do with that, we'll get to this soon. It's also deleting all the shadow copies. We'll get to this later too. Deleting shadow copies essentially means that you're deleting all the backups, all the backups the system can make. Essentially, you're using a vssadmin.exe, process vssadmin.exe, which is a legitimate Windows binary. We also see Samba, so might something to do with NetShares, desktop note, which I think is probably going to be the wallpaper stuff there. And yeah, lots of interesting stuff in here if we try to deepen our thoughts in here. So this whole thing will come, this whole information will come if we use the verbose option in here. So if we use verbose option in here, it will probably, it will give us all this as seen in the dynamic analysis portion. So with that being said, this is going to be a very high level analysis right now. We'll be going deeper and deeper into the reverse engineering portion of this malware. And we will see how it does stuff, why it's trying to do it, what kind of cipher it's going to use, how it's exactly killing the services and processes, how it's setting up the wallpaper, and something to do with virtual machine stuff in here, as we have probably seen in here. So yeah, keep on tuned with it, and it's going to be very interesting with this malware.